All right, today we'll be looking at using scatter plots to identify relationships. This is section 3.2 in your textbook, and there'll be some work to go with that that I'll be checking up on later on in the week, towards the end of the week. Just to review, our dependent and independent variables. In two variable data, there's often a dependent and an independent variable. In science, the independent variable is the one that we change, and the dependent is the one that we are measuring. We're trying to see if the independent variable has any effect on the dependent variable. So consider the following two variables: highest temperature of the day and the number of ice cream cones sold for that day. Which one's the independent? Which one's the dependent? The dependent is the thing that you're measuring. So in this case, the highest temperature would be the independent variable. That's the thing that you're looking at changing. So I'm just going to write the IV, and then write that next to temperature. The independent variable is that temperature, and the dependent variable is the number of ice cream cones sold for the day. So you might expect, if we were to graph that and we had that temperature on the y-axis and the number of ice cream cones C on the x-axis, that as the temperature increased, so would the number of ice cream cones sold. I don't know if it would be linear or parabolic or whatever, but you would expect higher temperatures would result in more ice cream sales. Independent, dependent variable. Just to continue on, consider the two variables: the number of years of post-secondary education versus annual salary. Again, we don't have to graph that, but the independent variable would be the number of years of post-secondary. The thing that you're measuring, the dependent variable, would be the annual salary. Let's do another example. Consider these two variables: time spent studying for a test and your mark on said test. The thing that you're changing, the independent variable, is the time studying. The mark on the test is the thing that you are measuring. So, again, conventional wisdom would say that more time spent studying will result in a greater mark. Some people fool themselves into thinking that's not the case, but generally that is the case. Third example: number of bags of chips sold and cost of a bag of chips. All right. So we'll have to think a little bit harder about this one. So a manufacturer that's making chips would want to get the largest price that they can get out of you where you still buy the chips. If they were charging $20 for a bag of chips, $50 for a bag of chips, well, nobody would buy them. $5 for a bag of chips, yeah, some people are buying them. When I was a kid, a big bag of chips was just $1. A little bag of chips was 50 cents. So, but as time has gone on, people are willing to spend more and more money for a bag of chips. So the cost would be the independent variable, and the number of bags sold would be the dependent variable. And in this case, as the cost of the bag of chips went down, I would expect that the number of bags of chips sold to go up. And just to end this little review on independent and dependent variables, the dependent variable will always go on the y-axis. This was the y-axis here. And the independent variable always goes on the x-axis, or the horizontal axis. Just for that last one with the bag of chips, I was thinking that as the cost of the chips goes up, the number of bags of chips should go down. So you'd get it going down like that. And, at a very small cost, you'd expect the number of chip bags sold to be quite high. Now, going back to our ice cream cone example here, let me just scroll down a little bit. I already kind of gave you a sketch of what I thought the general trend might be. But now let's look at, what do you think that sort of positive correlation might look like? It might look like something like that. Actually, I'm going to have it kind of plateau because there's only so much ice cream that people can eat. So you might get something like that. This would be your temperature down here. Let's say it's in degrees Celsius. To make a proper graph, by the way, you put the units in brackets like I did. Um, and then what are we looking at? Number of ice cream cones. So we're going to put number of cones. And there we don't need a unit because it's just a straight up number of ice cream cones. So, and we're seeing this positive sort of correlation. I attempted to freehand a straight line there. I don't know if this is a linear relationship or not. I'm just guessing that as the days get hotter, number of ice cream sold is going to go up. Again, just looking at dependent, independent variable. If I go to the next slide here, the three types of correlations to look for would be when the general trend is up, like that ice cream cone one that we just did. Actually, I'm going to use the example of the studying hours, and then mark. It would go up. I'll say that this one's in percent and this one's in hours. I expect your mark to go up in probably some sort of linear fashion like that. Maybe not such a great slope, but something like that. But regardless, this is called a positive correlation. Whereas the one that I talked about with the price for the bag of chips, we'll say that it's in dollars. And then the number bags of chips sold, I said that would probably be a negative correlation. And I'm going to write that is a negative. I'll write out the word instead of the lazy physics way. That's a negative correlation. When the slope goes down, when the independent variable increases and the dependent variable decreases, it's a negative correlation. If you're familiar with slope, that would be a negative slope versus over here we get a positive slope, and this one would be a negative slope. And the last thing to look for would be something that would give you no correlation, where there's no clear trend upward or down that you can see with your data. All right. And I don't know, what could we put there? For that we put temperature versus your grades, something like that. Maybe there could be a trend there. When it gets warmer out, you do less studying. But you might not see any sort of correlation from one thing to the next. Those would be the three types of correlations you're looking at in this particular section. In the next section, we'll be looking at lines of best fit and slope and things like that, and actually getting what the correlation is. But for this section, 3.2, that's all you really need to understand. So if you think you do, then over the next rest of today for this class and tomorrow, I'm not going to post a new lesson now until Monday. I just want you to work on page 142, 1 to 6, 8 to 12, and 16. I'm gonna figure out some way for you to communicate your work to me. Probably what you'll do is just do this on paper and then take a picture of it, and just to make sure you're keeping up so that I can give you a formal assessment towards the end and I know that you guys are there. I'll just look at marking your homework in a 1, 2, 3, or 0 basis, where 3 would be complete, 0 would be nothing, and then 1 and 2 would be your partially complete and almost complete levels. All right. So if I just give you a rating 0, 1, 2, 3, then that'll give me an idea. And I'll, as a medium weight sort of thing, I can just keep track and make sure that you guys are doing things. So at the end of this post, when you're ready to be done with section 3.2, I know you guys all have cell phones and are guns blazing on that stuff. Just go into Classroom on your phone and attach a picture of what you're working on, and just expect me to rate it 0, 1, 2, 3 out of 3. And I'll put that into Markbook and I'll count it just to make sure you guys are keeping up. All right. I'm not even going to set a due date for it. You're going to do it and you're going to get it done by next week, right? And then at the end of the chapter, I can see, well, this person did nothing, and surprise, surprise, they bombed the test, that sort of thing. It'll just give me some evidence as to why you're succeeding or why you are not succeeding in this course as we move forward online. All right, that's all for now, guys. Continue to email me if you have any questions or concerns, and we'll finish up chapter 3 next week. All right, that's it.